Welcome to the Authority Podcast, Plumbing and Mechanical. When talking about the built environment, we would do well to remember, we shape our buildings, and afterwards, our buildings shape us. Therefore, on each episode, we'll discuss the latest trends from IAPMO in plumbing and mechanical safety, sustainability, and resiliency. Join me, your host, Christoph Lohr, and together we'll explore the ways we can make our buildings shape us for the better. And welcome back to the Authority Podcast, Plumbing and Mechanical. I'm your host, Christoph Lohr, and it's my great pleasure today to have Jonah Schein, Technical Coordinator for Homes and Buildings with EPA WaterSense, joining me on the show. Jonah, welcome to Authority Podcast.
Oh, thanks for having me, Christoph.
Excellent. Well, I had the distinct pleasure of listening to Jonah's presentations at the Emerging Water Technology Symposium here in Scottsdale, Arizona, and also the Next Generation Summit in Santa Fe, New Mexico. I didn't get to listen to it just once. I got to listen to it twice, and just had many amazing, impactful moments in that. And I thought, for our listeners, we needed to get Jonah here on the show. Jonah, your presentation title was titled "Saving Energy and Reducing Carbon with WaterSense-Labeled Homes," and it was a granular case study that discussed the impacts of water efficiency and how that can impact energy consumption and carbon emissions. And you used a couple of case studies of WaterSense-labeled homes in Southern California to kind of highlight how those detailed estimates can be used to estimate energy usage and in the different phases of the water supply cycle. Can you kind of frame the problem a little bit for our listeners that you discussed in that presentation?
Sure, Christoph. And, I'm going to assume anyone who cares enough about water and plumbing codes and everything to be listening to this podcast, you probably know that, hey, guess what? Water and energy are inextricably connected. That's not necessarily news to us anymore. But what we're trying to do with this with this study is maybe take it a step further beyond this really high level connection and talk about what are the specific influences that using water more efficiently can have, and how do we capture and quantify them. And when you think about it, and I'm going to share something for anyone who's following along on video, you have to take a step back and ask yourself, well, every gallon of water has a specific signature. And that variability could be a lot, right? It could be easily 10x from one location to another. So we have to sort of start with this question of, I've got this gallon of water. I know it took energy and carbon to get it here to where I need it. How much? And that's really a function of a lot of different things, right? I mean, starting with extraction. What do I have to do to get the water? It doesn't just exist right where I need it. Do we have to pull it out of a river or surface water? Do we have to drill it out of the ground? Do we have another form of capture available? That all takes energy. Where we get it from is also going to influence how far we have to move it. Once again, it doesn't do us the favor of locating itself right where we need it most of the time. We're going to have to move it. Water's heavy, right? 8.35 pounds per gallon. So we've got to move it to where we need to go. Every source is also going to have a different quality. That means we have to treat it. And the amount of energy we put into treating it is going to vary based on where we got it from and what the quality of that specific water is. From there, we've got to get it out to our homes and our businesses and our community where we're going to use it. And how we use that water is going to influence it as well, right? Some of it we'll use outside, and that's pretty much the end of the story as far as its energy signature goes. Some of it will go down the drain and have a sort of second life of energy consumption as we handle it as wastewater, which also has an energy impact. And then some of it's going to be heated, which adds even more of an energy burden and embedded carbon to the water that we use. So it's a lot of information we have to sort of take and process to really answer this question of, I have this gallon of water, I used it. What's the impact on energy and carbon as a result of that?
Excellent. We put up on the screen again for our video listeners, as Jonah mentioned, just that snippet of his presentation that showed that. I'd say, does that kind of capture all you mentioned the energy usage, right, for water. And I think that was one of the most impactful things for me, was how you linked the delivery of water and the usage of water, and the energy associated with that, with the water consumption portion of it. And I think what was really impactful to me is you kind of showed a couple of those 2 case studies, and there were some really significant results from that. And I guess we'll put that up on the screen here as well. Can you touch on a little bit, for our listeners and viewers, some of the results that you found from that connection between the energy associated with water and water usage?
Yeah, exactly, Christoph. And that's really what we were trying to accomplish here, right? In this instance, our case study is taking place at 2 communities in Menifee, California, built by our longtime partner, KB Home. It's 219, or will be at completion, 219 WaterSense-Labeled homes. So these are homes that were built very specifically with water conservation in mind. They've got WaterSense-Labeled products. They have design features. They have technology that was chosen specifically to use water as efficiently as possible. And what we found from these 219 homes, we expect that they'll save about 3.4 million gallons of water a year across the two communities, which is a lot of water, but that's also not new. We expect WaterSense-Labeled homes to save a lot of water. But when we go in and we drill down to, because of the mix of sources that we're using to supply this community, and because they're WaterSense-Labeled, we have a really good lens into the granular details of how these homes are going to use water. Well, in total, they're going to save about almost 640,000 kilowatt hours per year and almost 358,000 pounds of carbon each year, just by using water, just related to their water use, their energy and carbon impact associated with water use. So it's really a pretty significant impact that we're able to have, and we can pinpoint exactly where that impact is happening and what the design and technology choices that resulted in those savings are.
Yeah, and that's really helpful, Jonah. And that part, to me, those total numbers for those 2 communities was oh so impactful for me. That was when I remembered hearing from other folks at different conferences, especially like here in Arizona, the amount of energy that goes into getting that water to places like where I live in Phoenix, Arizona, and just the methodology you had there, in terms of the problem and that solution, the results. That was, again, it just really stuck with me. For our listeners' sake, can you kind of maybe help them connect the problem that you described at the beginning, and then the results you received? And again, we can share screen here again from your presentation for our listeners' benefit, our our video users' benefit, and maybe you can describe it for folks, kind of the how that all kind of fits together.
Yeah, absolutely. And I'd say, Christoph, there's 3 sort of big data pieces we need to model this all together. Lots of little pieces as well. And anyone who's ever done, any type of energy modeling or large scale water use modeling can certainly relate to that. But first and foremost, we need to know what are the sources of water that we're going to use to supply, in this case, the Eastern Municipal Water District, the utility that's serving these communities. What are they going to use to supply these homes? And in the case of California, we can always get that information. Eastern Municipal would have given it to us. They participated in this study. They're a great partner of ours, and are very enthusiastic about the prospect of saving water, using water efficiently, saving water, and the resulting energy impact as well. But we can always get it from the water management plan for any utility in California. We need to know what the source energy intensity on a source by source basis are for this specific location. Right? So the state water carrier, for example, the state water project, isn't going to have the same signature for conveyance in Southern California as it would in the Central Valley. Right? We have to take it a lot further to get it all the way to Menifee, and that means that its signature is going to be a lot larger because of the additional mileage it has to go.
For our listeners' sake, John, can you kind of describe some of the numbers? Maybe just kind of give them a range of, the energy intensity from the source. What were some of the ranges that you found in as part of this case study?
Yeah, and once again, for anyone who's following along on the video, I'm going to put these numbers up here. But for anyone who's listening along, you can either go to the video later, or you can find this in the report that's available on our website as well. But Christoph, the ranges are huge, right? I mean, depending where the water comes from. I mean, in total, it's more than when you add everything up, right, from start to beginning. From that, going back to my original point, right, from extraction all the way through sort of the end of the story, so to speak. So potentially all the way through wastewater treatment. That's a variance of more than 20x, depending on where the water comes from and how it's going to be used in the home. So, I mean, again, you really do need to understand all of those factors, right? Where's the water going to come from? What is the proportional mix? How are we going to use it in the individual home, or how are we likely to use it in these homes? Again, because of the technology and the design choices that we've put in place. Otherwise, you might be 1/20th, estimating 1/20th the actual impact.
And this slide, I'm so glad you put this one up. So for audio viewers, I mean, this was probably one of my favorite slides, the one that really impacted me. I had heard about Arizona, especially the Phoenix water was very energy intensive, but just for our audio only listeners, I mean, local imported water extraction conveyance was 33 kilowatt hours per acre foot. And this, Colorado River was like 2,000 plus kilowatt hours per acre foot. The state water project was over 3,000 kilowatt hours per acre foot. I mean, Jonah, this slide here was so impactful for me. And it reminded me of this conversation or this post I put out on LinkedIn maybe a year or two ago, where a lot of people were saying, oh, desalination is the solution. And to me, at that point, I was starting to make that connection between energy and water. And it's like, keep in mind, if you put that desalination plant up there, there's some you show it too, that there's energy requirements to push it through the RO membranes, to get the salt out of it. And when I did
right.
Yeah. When I did the calcs, Jonah, at a home by home basis, it was like you could, like, without any new energy sources, the equivalent of getting your water from desalination was similar in the range of your refrigerator running. So it was kind of like, would you rather have, without any new energy sources, would you rather have that water coming out of your tap or having your refrigerator run? Pick one. And it's one of those that we have to think about that nexus. And that's where, again, this slide here was one of my favorites in your presentation. It was so impactful to me because it really kind of showed that range.
Yeah, no, and I mean, we do have, there is some desalinated water used here, but it's brackish groundwater, right? Which means it's not quite as salty as sort of like seawater desalination. Eastern Municipal doesn't have access to any Eastern. It's not part of the sort of water portfolio in this case. If it were, I think in Southern California, I believe the number just for treatment. So just, again, for anyone who's listening along, we have it broken out into basically 4 columns here, or 4 categories here: extraction and conveyance, treatment, distribution, and potentially wastewater.
Yeah.
Just treatment for desalinated seawater is about 8,000 kilowatt hours per acre foot. So, wow. Right now, the largest, again, as Christoph was mentioning, these values range, right? They might be as low as, again, just for treatment, 205 kilowatt hours per acre foot, all the way up to 1,400 kilowatt hours per acre foot. So we're seeing all of these tremendous energy and carbon savings, but that's without desalinated seawater. Yeah. If we start adding a bunch of desalinated seawater to the portfolio, that's going to skyrocket. And that's one of the reasons, that's one of the things that makes it just so expensive.
Yeah. I was going to say, I don't know if you want to go back to that other slide, the Venn diagram you had, if there's anything else you want to wrap up there. But again, that slide with the numbers, that one, as an engineer, for me, I was blown away. And that really solidified that main point that I've been thinking about for a while, which is that energy and water are so linked, and the amount of water we use there's such an energy component behind it. Whatever it does to get out of the tap, there's energy behind that, and we can't forget that. Is there anything else you wanted to chat about with our listeners?
Yeah, the one other thing I think that's really resonated with people is, well, when you think about it, at this community, and we didn't get into details on this, but it's, in addition to being a very water efficient community, it's an extremely energy efficient community. It's got a microgrid to help reduce its carbon. It's got solar power. It's got the absolute top of the line in terms of heat pump water heaters. And so it's great when you think about it, right? Because we've got these 3 different strategies to help reduce the energy and carbon impact of water in this case, right? We've got the microgrid, we've got the heat pump water heater, so more of a conventional energy efficiency strategy, and we have water efficiency. And one of the questions, the first time I started sharing this work with anyone, it's a very natural question: is what gets attributed to each strategy? And in practice, it's sort of an impossible question to answer because everything's happening simultaneously, right? Did you reduce the water use first, or did you reduce the energy you needed to heat the water first? It's sort of a philosophical question. But what we can do is we can isolate each of these and compare it to sort of a reference, right? So if we were to only do one of these strategies, and again, for anyone who's following along, we can look at that, right? And we can model it. So, in the case if we just did the microgrid, but we didn't do anything else, right? So we're not doing anything to save energy, we're not doing anything to save water, but we are making sure that energy that we're using is carbon free, right? Well, don't save any energy that way, but we do save a lot of carbon, about 289,000 pounds of CO2 per year. If we were to just do the heat pump water heaters, and not do anything else, so we're not doing anything, we're just pulling off this quote unquote dirty grid, we're not doing anything to make the homes more water efficient, but we are being efficient with how we heat the water. That's about 221,000 pounds of carbon reductions per year. And if we were to just do water efficiency, so nothing with the efficient water heaters, nothing with just pulling our energy off the quote unquote dirty grid, but just using water more efficiently, we'd save 119,000 pounds of carbon per year. So we're going from 289,000 pounds with the microgrid scenario, 221,000 pounds with the heat pump water heater scenario, and 119,000 pounds per year with the water efficiency scenario. And so maybe that's sort of 1, 2, 3. Maybe that's the order you might have guessed in. But what if we start putting dollar figures associated with this?
Yeah.
Right? And we look at it from the point of view of dollars per pounds of carbon that we avoid. Well, all of a sudden, water efficiency shoots off the scale here, right? There's so much low-hanging fruit when it comes to using water more efficiently in our homes, in our communities, that it's really a tremendous opportunity to save energy and save carbon while also saving water.
And I think the slide after this one, you showed that one of those studies too that showed when you put the dollar figures. This one was the other impactful one. This was my second favorite slide.
Yeah, and again, Christoph, I started putting this in because, and this is for anyone listening around. This is actually looking nothing to do with my study, right? This is an analysis done by folks at UC Davis of the 2015 water use reductions that were ordered in California. And basically what they found was that the water efficiency measures that were ordered in response to the mid-2010s drought in California saved about as much energy as all of the state's energy efficiency programs. And yet it costs like 1/4 the amount of money. So I put this in to show, once again, this is not new. I'm not the only one to find these results. Yeah. Right. And hopefully that lends some, it's not just Jonah going on about things as like the one crazy guy. Other people have found the same thing. For some reason, we have a tendency to forget about it, but I think it's really something we need to hang on to and internalize a little bit more.
I would agree, Jonah. And actually, it reminds me that we have the Water Demand Calculator Summit coming up on November 12th of this year, of 2024. And you're working on a presentation. You're actually one of our presenters at the summit this year. And you're going to touch a little bit more on there's more of a general topic of water efficiency. At IAPMO, we're seeing the same thing as you, Jonah, which is that water efficiency in terms of right sizing does have an impact on water and energy usage, and there's reduction opportunities there. For your presentation, though, you're looking at the calculations and you're looking at right sizing from a length perspective. Can you give our listeners maybe just a little sneak peek on that topic of what you're looking at, maybe some of your initial calculations as you're preparing for that presentation?
Yeah, absolutely. And, to be fair, the modeling that we're using at this stage is sort of just the tip of the iceberg when it comes to what truly right sizing a plumbing system can do. We're not capturing diameter size of piping because there's, I think if you think this through, if you can probably see how there'd be some challenges consistently collecting that information in the field. But we do capture run length data. And what we found is that the 219 homes that we're looking at in Oakshade and Durango and these communities in Menifee, they've reduced the total run length of piping by about half. And so they're, on a sort of average reference home, we would expect, on average, these homes to have about 100 feet of total piping in them, and the homes that we're certifying, they're closer to around 45 to 50. So again, just the absolute tip of the iceberg when it comes to right sizing. Anecdotally, I'd say, where does that come from? It probably comes from two things. One, eliminating the absolute worst design features, right? So like the kitchen sink that's like completely shoved all the way as far as can possibly be from the water heater and has a line running in a conduit under the slab or something, right? We can, it's very difficult to convince builders to actually change the layout of homes, but there's some things which are, truly sort of egregious from a design and performance perspective that we can help them eliminate. The other is honestly probably just drilling into to the builders and in turn their site foremans and superintendents, who in turn turn around to the trades and say, hey, don't let me catch you running this thing in a circuitous route, which if you've ever walked a new home construction site is all too common of a site, right? We're going to take direct lines. We're going to eliminate those unnecessary routings and things that just tend to add a lot of run length. And just doing that reduces the run length by about half.
Wow. I'm really excited for your presentation at the summit this year. So for our listeners that want to learn more, that's a great chance to kind of look at the next sort of phase of all this research here. So as we wrap up here, if you were going to summarize your talk here today with us on the podcast in one word, what would that one word be?
I think the word has to be opportunity, right? It's just, again, there's so much cost-effective, low-hanging fruit when it comes to using water more efficiently, and we know that has an impact on saving energy and saving carbon. It feels like we're bending over backwards trying to reduce carbon right now, and this is probably a technique we could use a lot more.
Excellent. If our listeners want to learn more about the report or get in touch with you, what's the best way for them to do so?
So the report's available on our website. We can, hopefully we'll drop a link in the description. And always, feel free to connect with me on social media or via the WaterSense website.
Excellent. Well, on behalf of the Authority Podcast, Plumbing Mechanical, and IAPMO, Jonah, I just want to say thanks again for your time today. It was a real pleasure having you on, and I'm looking forward to seeing you again at the Water Demand Calculator Summit.
Sounds good. Looking forward to it, Christoph.
Thanks for joining us on this week's episode of the Authority Podcast, Plumbing and Mechanical. Love this episode of the podcast? Head over to iTunes to subscribe, rate, and leave a review. Please follow us on Twitter @AuthorityPM, on Instagram @TheAuthorityPodcast, or email us at iapmo@iapmo.org. Join us next time for another episode of the Authority Podcast, Plumbing and Mechanical. In the meantime, let's work together to make our buildings more resilient and shape us for the better.